So let's take a look at the security implications and attack surfaces involved in data-intensive science traffic and enterprise traffic. So we're going to use the Globus data transfer application as a proxy for traffic you'd see on your DTN and your science DMZ. We're going to use a web browser as a proxy for enterprise traffic. And we're going to look a little bit at the capabilities and attributes of each and see which is more or less dangerous in different environments. So the reason it's useful to do this is a traditional security approach says to put everything behind an enterprise firewall, which is often a poor performance fit for something like a data transfer node. So the question is it possible to move the data transfer node outside the enterprise firewall and still have it be safe just with access lists for packet filtering? So if we look at a web browser, what does a web browser do? It connects to a web server on a well-known port. It downloads a text file, which may be auto-generated by the web server or generated on the fly by the web server, but it downloads text and begins rendering the text. In that text may be items to say include this image file, so it goes and fetches the image file. It may say there's a movie that needs to be played by this player over here, so I'm going to go get the movie from here and the player from over there. There's a whole bunch of these different things that come down, and they come from all over the internet. It's impossible in general to attribute the different portions of a web page to the site that you nominally went to download the web page in practice. So if we look at a DTN, a data transfer node doesn't run that sort of commodity application. What does it do? It negotiates a transfer with a remote DTN, open a few data connections, write out a couple of terabytes, and close it all down. If the data is being written to your DTN, in other words, you're not serving data to the outside world, but you're bringing data in and you're writing it to disk on a machine you control, presumably the person doing that has access to that machine by means of an account that your organization has given them. So you've vetted the person who's actually writing the data to disk already. If we look at the attack surface associated with the commodity traffic, it's actually pretty large. So if you look at what's happening in that web browser, there's mobile code that's coming down. The rich media content that's coming down is invoking players, sometimes multiple players, different codecs, different image rendering libraries. There are a whole bunch of things that happen, and quite a large array of code and libraries get called and executed. So in terms of software, that attack surface is really, really large. And you can take a look at this. Say your users are into sports or celebrity gossip or something like that. Go open up one of the popular websites for this. Turn on the JavaScript debugger and look at what all comes down. It's amazing the amount of stuff that comes down. Text comes down and gets executed as code. There's all kinds of stuff you can see in there. And this is just what happens in the course of normal web browsing. This all comes over the standard ports of port 80 and port 443 that firewall people know and love and leave open to the outside world. If you look then at what the science traffic does, there's one listening service, it's Globus on port 2811. There are a couple of additional ports open for authentication protocols, and then a large range of ports for individual data connections, because Globus is a parallel data transfer tool, so it needs a set of ports that are open for those parallel data transfers. In a standard install of Globus, that's 1,001 ports 50,000 to 51,000. It's a large number of ports, but if you look at what's happening across the data connections that traverse those ports, it's nice, clean POSIX file operations. It's open, read, write, and close. That's it. There's no mobile code, there's no image rendering, there's no media players, there's no rich content, there's no document readers, none of that stuff. It's just straightforward file operations, just with large-scale data. So which has the greater attack surface? The thing that opens two ports and executes this gigantic array of software that quite often has vulnerabilities in it. When was the last time you patched your web browser? It should have been within the last month. Or is it the data transfer tool that requires 1,000 ports, but only does simple, clean, system-level operations to write data to files or read data off a file system? So I would argue that it's not rational to consider the application with two ports to be a lesser security risk when there's this gigantic array of software behind it that routinely has vulnerabilities versus an application that has a larger number of ports but is clean and well behaved from a security perspective. So I would argue to each its own. The enterprise traffic should be protected by an enterprise firewall. We need that sophistication because of the risk profile of applications running in the enterprise network. For the Science DMZ, where we have a stringent set of performance requirements and a relatively simple traffic profile from a network security perspective, we can use a reduced set of high-performance security controls to defend the Science DMZ from the attacks that are mountable against the applications running in the Science DMZ.